All right, hi everybody. So in this lesson today, what we're going to take a look at is putting transformations together. And we're going to do this in two lessons. This is just going to be part one. So now we're going to take a look at expressions, at functions, at questions, graphs, and whatever, where we're going to have multiple transformations that have taken place here. Now, they should be completed in alphabetical order, RST, reflection, stretches, translations. Well, yeah, alphabetical isn't really the important thing here. What we need here is we need reflections and stretches to come first because this is the result of multiplication. And then we need translations to come later because this is the result of addition subtraction. So, really, what we're talking about here is order of operations. And in fact, it doesn't even matter. You could do stretches and reflections because order doesn't matter for multiplication. It's just as long as those things come first when you perform them. Now, that's not to say that in the question that you're going to be working on, okay, that the person giving you the question has done it in the correct order. But when you read the transformations off of an expression, you will read it in that order. It won't be obvious to you. If they've done it in a different order, that will not at all be obvious to you. Okay, so you have to kind of read it in a standardized way, reflections and stretches, and then translations. But I'll add to this that we mean this order sort of for each direction. So, like the vertical transformations and the horizontal transformations. I can do a vertical stretch before I do, I can do a horizontal, let's say, translation before I do a vertical stretch. That's not going to cause a problem. It's when they're in the same direction. Anyway, so in all this as well, when you're doing problems here, uh, you're looking at translation should be last unless otherwise stated. Oh boy. So you have to watch for words like then and followed by in the question so that you can follow what it is that they're telling you to do correctly. Now, what we've got here is just these general expressions here. So you'll take a look at we've got y equals af of b times x minus h. Can I close the function off and then plus k? Or we got the other way of writing it there. We just want to go back over what these parameters are doing. So remember, A is responsible for the vertical stretch. It's also responsible for the vertical reflection. B is going to be the horizontal stretch. It's also going to be responsible for the horizontal reflection. But notice it's going to be 1 over B. Okay, because we're gonna have to flip it. If you were to isolate the x, you'd have to reciprocate that coefficient to make that work. H will be the horizontal translation. Just remember how that works. If H is positive, it goes to the right. If H is negative, it goes to the left. But there is a subtraction inside there. So remember, it's x minus h. Okay, it's subtract h. So if I've got x minus 2, h is equal to 2. If I've got x plus 3, h is equal to negative 3. You just have to be reading that correctly off of the graph there. And a very similar sort of thing is going on with k, which is going to be our vertical translation. So a couple of things to note before we take a look at some examples here. The most common error, and this one really needs to be highlighted. This is something that's going to get tested over and over again. In fact, we're going to test this in different chapters. Okay, when we start talking about trigonometry, we start talking about logarithms and kind of more general polynomial functions, we are going to test to see that you are factoring out the horizontal stretch from the translation. Okay. If you translate something first, let's say horizontally or vertically, it doesn't really matter. But if you translate something first and then stretch it in the same direction, the stretch changes the translation. Okay, because when we stretch objects, we're not stretching them about their middle. Everything gets stretched from an axis. It's always away from or towards an axis. And so if you move something away or towards the axis, typically away from in most of the cases that we're working with, your stretch that comes afterwards is going to change that. And we're going to see some examples where that's exactly what we're looking at. It's also important to make sure that y is by itself on the left-hand side before identifying any vertical transformations. And this is actually for exactly the same reason as that previous note here. It's just with the vertical items there. If you leave the stretch on the left-hand side, but you move the translation over, that translation isn't quite correct yet. And you'll see what I mean when we take a look at some examples here. So now let's take a look at some examples. So let's take this look at this first one here. The original point, negative 1812, is on the graph of y equals f of x. So this is the original. What are the coordinates of the image point under the following transformations? Okay. So, well, first of all, what I need to do here is make sure that it's abundantly clear the difference between the transformation, this translation and the reflection here. So I have to factor out a negative, and that'll make that x plus 6. And now it is more obvious to me what's going on here. What I'm seeing here is a horizontal reflection. So it's going to make x negative. And then what I'm doing here is moving this 6 to the left. So I'm going to subtract 6. Okay. And then over here on the y, it's going to be 8 down. But I have to factor out that negative. Otherwise, you might interpret that as 6 to the right. Okay. But there needs to be a separation between that coefficient and the translation. But now I can just put negative 1812 in. So it's going to be the negative of negative 18 minus 6, and then this is going to be 12 minus 8. So what is that going to be? That's going to be positive 18 minus 6 will be 12. 12 minus 8 is going to be 4. Okay, I'm just going to double check. Yeah. Now here, the x is not a problem. It's just a horizontal translation 5 to the left here. But what's going on with the y? Well, what I might do is bring over that 4. So it looks like this. So I'm going to add 4. But here's the thing. That looks right now like it's 4 up. But it isn't, because what I have to do now is multiply that 3. I got to bring that 1/3 over. So I'm going to multiply everything through by 3, but I have to multiply the entire right side by 3, which means that 4 also gets multiplied by 3. So this is 3 f of x plus 5 plus 12. The stretch affects the translation unless I've separated them. And in this case, I haven't. So now I've got x comma y is going to become, well, again, it's not a big deal here. That's x is moving 5 to the left. And then because I've moved everything over, it's the transformations are exactly what I'm reading. It's going to be 3y plus 12. So negative 1812 is going to become, negative 18 minus 5 is going to be negative 23. 3 times y is 36 plus 12 will be 48. So negative 23/48. Now this last one, everything's been isolated. There's nothing to factor out inside the function. So actually we can jump right to our mapping. I see a 1/2 x inside the function. So it's going to be 2x in our mapping. And then since everything is brought over and we've isolated y, the transformations are exactly what I'm seeing. So negative y plus 1. So negative 1812 will become negative 36, and then negative 12 plus 1 will be negative 11. Okay, and there you go. That's what's happening to that point in each of those different transformations there. Now let's take a look at question 2. What we want to do is write the equation for each transformation. We're going to take y equals f of x and transform it. We're just going to take the transformations that they give us and plug them in. So here we go. A vertical stretch by a factor of 1/3. Okay, let's just write down the replacements here. If I stretch something vertically by a factor of 1/3, I'm replacing y with 3y. And then a horizontal stretch by a factor of 1/2 means I'm going to replace x with 2x. And then a reflection in the x-axis. And I got to think about that. A reflection in the x-axis is a vertical reflection, so I'm going to replace y with negative y. So, and I'll just do this little bit by little bit here. So that's going to be, I start with y equals f of x, and I'm going to make this 3y equals f of x. Okay. I'm going to bring that 3 over, make that 1/3, and then I'm going to also replace the x with 2x. I can do those both in the same step because they're in different directions entirely. They're not affecting each other. And then I'm going to replace the y with negative y. When I bring that negative over, I'll get y equals negative 1/3 f of 2x, which means my mapping coming back to here now is simply going to be 1/2 x negative 1/3 y. And I know we've said this before, but just notice that my mapping reflects exactly what was described. Vertical stretch by a factor of 1/3, I multiplied by y by 1/3. horizontal stretch by 1/2, I multiplied x by 1/2. So like that's the mapping corresponds really, really closely to the description of the transformations. Let's take a look at this one. A horizontal stretch by a factor of 2 means I'm replacing x with 1/2 x. Reflected in the line y equals 0. Okay, I got to think about that. Reflected in the line y equals 0. That is the x-axis. So that means I'm replacing y with negative y. And then I'm going to translate this thing 7 units up, which means replacing y with y minus 7. Now, we really want you to see how this works here. So we're going to take y equals f of x. First thing I'm going to do is I'm going to replace the x with half x. So I'm going to basically, I scratch out the x that's there, and in its place, I put 1/2 x. Then I scratch out the y that's there, and I plug negative y there. Now, here's where oftentimes people make mistakes. The next thing I'm going to do is I'm going to replace y with y minus 7. But notice that in this state that it's in right now, I am multiplying the y by a negative 1. Now I'm going to replace y with y minus 7. But this is incorrect because I didn't actually replace the y. And I know people are going to look at that and get a little frustrated, but look at it. I am multiplying in the previous step, in this step right here, I am multiplying the y by a negative 1. In this step, after I replace it, the y is being multiplied by the negative 1, but not the negative 7. So clearly I didn't replace that properly. I need to put parentheses around that to make sure that that is in fact what's going on here, that the y was completely replaced. Now, in order, I will bring the negative over, and then I will bring the 7 over. So this becomes negative 1/2 x plus 7. So now I can get my mapping a lot better. This will be 2x and then negative y plus 7. Okay, and then we'll do one more here in this question. A horizontal shift 3 units to the right, okie dokie. So that means I'm going to replace x with x minus 3, followed by a vertical shift 2 up. Okay, that's going to be replacing y with y minus 2. Then, here we go. Then a horizontal stretch by a factor of 1/2. Okay, this question is forcing me to do this in the wrong order. So what I can tell you right now is before we even get into this, I know that translation, that horizontal translation, that's not right. That's when this is all over, that 3 to the right is not going to be what actually happened here. So a horizontal stretch by a factor of 1/2 means replacing x with 2x. A vertical stretch by a factor of 4, yeah, we did it here too. I'm going to replace y with 1/4 y. Again, I know that my vertical translation is incorrect. And here's why. Here's how this works. So we start with y equals f of x. Then I replace x with x minus 3. Then I replace y with y minus 2. Now I'm going to replace x with 2x. Now, notice what's going on here. The 2 is not multiplied by x minus 3. The 2 is multiplied by the x. In this step right here, I was simply subtracting 3 from the x. So if I replace x with 2x, I'm now subtracting 3 from 2x. But there's a horizontal stretch there. I need to factor that out. And when I factor that out, I have to take it out of both terms. So now, in reality, I didn't move this thing 3 to the right. I've actually moved it 3/2 to the right. Now I'm going to do the same thing with y here. I'm going to replace y with 1/4 y. So this is going to be 1/4y minus 2 equals f of 2, x minus 3/2. Okay, I don't put parentheses around the y minus 2 because in the previous step, I'm simply subtracting 2 from y. So now after the replacement, I must be subtracting 2 from 1/4 y. Then I will bring, I'm going to write a little bit smaller here. I will bring that 2 over. And now, just like in a previous question, I'm going to multiply by 4 but I must make sure to multiply everything through by 4. So that 2 up, has now become actually 8 up. And now I'm in a better position to read my mapping off of this. That 2x there becomes a 1/2 x plus 3 halves. And then y becomes 4y plus 8. It's really important to pay attention to that. When they do this in the wrong order, that means the stretch that they get, the translation, I should say, the translation that they give you is incorrect. And you won't be able to read it until you're done and you've simplified those. So in this next question, we're going to take a look at point 8 comma negative 3. And that's going to be on the graph of y equals f of x. And we want to know what the coordinates are of the corresponding point on this guy right here. Now I'm pleased that the negative 3 and the 1 have been moved over, but I need to make a little adjustment here because I can see inside my function that 2 has been multiplied through, and I need to factor it out. So this becomes 2 times bracket x minus 2 plus 1. And so now my image point is going to be, well, to the x, I've got a stretch by a factor of 1/2, and then I moved it 2 to the right. But for the y, it's going to be negative 3y plus 1. So now I take the point 8, negative 3, and here we go. Half of x, half of 8 is going to be 4, plus 2 is 6. Then I take the negative 3 and plug it in. Negative 3 times negative 3 is 9, plus 1 is 10. So the new point becomes 6, 10. 8, negative 3 becomes the point 6, 10. Now we're going to look at this in a little bit more detail. Take a look at this question. We're going to take this function here, which is clearly a pieced together function. Okay, it looks like a cubic and then a little linear there. And what we're going to do is we're going to transform it in this way here. Now, nothing is particularly clever has been done with the transformations. So my mapping is going to be x comma y is going to become x plus 3, just 3 to the right, and then negative 2y plus 1 is what we're seeing here. So this question is just to give you some exposure to one way that you might transform these things. Some of you are going to be very gifted in that you can really see in your heads where these things are going to move and how the transformations work. Others also are going to struggle a little bit. So one way to do it is to simply take the points and plot them. So here we go. 3, negative 2 is going to become, well, I'm going to plug the negative 3 in. So negative 3 plus 3 is 0. Negative 2 times negative 2 is 4, plus 1 is 5. So that first point there becomes the point 0, 5. So it's going to go right there. Negative 1, 0. Well, negative 1 plus 3 is 2. Negative 2 times 0 plus 1 is going to be 1. So it's going to become 2, 1. So it's going to go right there. And those points were connected by a straight line. 0, 4. Well, 0 plus 3 is 3. Negative 2 times 4 is negative 8. Plus 1 is negative 7. So 3, negative 7 is going to go down here. 2, 0. 2 plus 3 is 5. Negative 2 times 0 plus 1 is 1. So 5, 1. And then finally, 3 plus 3 is 6. Negative 2 times 5 is negative 10. Plus 1 is negative 9. So that's going to drop down. Sorry, that was 6, 9. It's going to go there. Nope. Oh, it's right off the screen there. So 6, 7, 8. Yeah, right there. So here we go. The graph's going to go up, down, and up like that. And then you just connect the dots in a way that reflects the shape of the original function you were working with. Okay, everybody. So this question here, when I go over this one in class, this is one of those questions where I back off and I let people have a look at it first. So we want you to describe the series of transformations that take y equals f of x. So in this case, it's going to be this graph and transforms it into this one. All you have to do is identify what the graphs are. And then again, this one down to this one. You just have to write them out in order here. So this would be a great time to maybe pause the video, have a look, and see if we ultimately get the same results here. The reason why I want people to do this is because there tends to be a bit of an error made here. So have a look and then come back. Okay, so here we go. So I think for this one, it's pretty clear that the very first thing that happened here, and you can play with this a little bit, but that there was there was a horizontal stretch by a factor of a half. The distance between these 2 points is 6. The distance between these 2 points is 3. Now, what's important is that people catch what that does. When you stretch something, you actually stretch it about the axis. So I'm going to take this x coordinate right here, multiply it by a half. It's going to go to -2. This coordinate at -8 is going to go to -4. This one at -2 is going to go to -1. And so the stretch does that. There will be a lot of people out there that will have done it wrong at this point, because what you will have done is you'll have left it at the center. Okay, what I see a lot of people do is they leave the center here at -4 and then they draw it out like that as their stretch. But that's not how stretches work. The stretches are always about the axis here. Now, after that, there's been a vertical reflection, and so the points flip positions. So this -2, 3 becomes -2, -3. And those other 2 points are going to flip up. So it's going to look like this. Some people in this case think that there's been a horizontal reflection, but actually it hasn't. You'll notice that this graph is skewed a little bit to the right. Even after it's been moved, the G graph is still skewed a little bit to the right here. But now all I got to do is move this point over here. And so that means 1, 2, 3, 4, horizontal translation 4 to the right, and then a vertical translation 4 down. Now, I'm using a real shorthand here. This is not great. And if you were to do this on an exam, you should really write that all out. But just for the sake of time here and to get you through this, horizontal translation by a factor of 1/2 about the y-axis, vertical reflection over the x-axis, horizontal translation 4 to the right, vertical translation 4 down. This next one here, what's key about this one is what you want to catch here is that these points right here are supposed to be these points. I think it's pretty obvious that there's been a vertical reflection here, but what might be less obvious is that to go from this vertex right here to, let's say, that point, I go 1 unit over, 1 unit up. But now it's like 2 units over, 3 units up. And we want you to interpret that as a horizontal stretch by a factor of 2. So it's 2 units more. It's 2 units horizontally, and then a vertical stretch by a factor of 3. None of that's going to affect this vertex right here, though. So then all I have to do is translate that vertex 3 to the right, and then a vertical translation 4 down to get us into that location there. But again, just connecting those points and seeing the points from the original to the points in the transformed one. So now in this example here, we're going to complete the table. So we're going to take that in the first row here. We're going to take the point -1, 6. We're going to reflect it in the line x equals 0. So really what we want to do is we want to follow the image point, what they're giving us here. So reflected in the line x equals 0. Bear in mind, x equals 0 is the y-axis. So that means x is going to change signs. Horizontal translation 3 to the right means in the image point, I'm actually going to add 3 to the x. And then a vertical translation 2 down means I'm going to subtract 2 from the y. So when I take -1, 6 and plug this in, the negative of -1 plus 3, and then 6 minus 2, that is going to become the point. Whoops, all of a sudden it's not writing. Okay, keep playing with it here just a little bit. It's going to become the point 4, 4. Okay, so for the next one here, the same sort of thing. We are simply watching what's going on with the image point. A vertical stretch by a factor of 2 about the x-axis means we are going to multiply x by 2. Now notice this is going into the image point. This is not a replacement going into the function. So when I say it's a vertical stretch, a vertical stretch by a factor of 2, I mean I'm going to multiply y by 2. And a horizontal stretch by a factor of 3 means I'm going to multiply x by 3 here. Okay? This is just, we're going to take exactly what we're seeing there and translate that into the point. Okay, it's only when you go into the function that you're going to see that those replacements flipping those things, where the horizontal stretch by a factor of 1/3, by a factor of 3 actually becomes the 1/3. So in this case, 3 times 3 is going to be 9. 2 times -2 is -4. Now here, watch how this one's written. We're going to replace y with -y. And then we're going to replace y with y plus 2 and x with 3x. Okay, now that's different. When we talk about it as in terms of a replacement, now we're talking about what's going to happen in the function. Now, replacing y with negative y is going to be a vertical reflection. That's really just going to make the y negative, so that's really no different. But if I replace y with y plus 2, that means the graph is actually going down 2. If I replace x in the function with 3x, that means there's going to be a horizontal stretch by a factor of 3. Because when we talk about the replacements that's in the function, that is actually going to look a bit opposite to what the actual transformation is. So now 1/3 of 6 is going to be 2. And then the negative of negative 3 will be positive 3 minus 2 is 1. So 2 comma 1. Here, in order to get this image point correct, what we got to do here is simplify what's inside there by factoring out the 1/2. And that is going to become x minus 6 plus 1. So our image point here is going to be x comma y. Okay, there's a horizontal stretch by a factor of 2, and then I moved 6 to the right, so plus 6, and then 2y plus 1. Now, what typically happens in a question like this, I'll get people wondering, well, why did that become negative 6? Why didn't that become negative 3/2? And the answer is because I'm taking that negative 3 and I'm dividing by a half. I'm not dividing it in half. I'm dividing it by half. And when you divide by a half, that's the same as multiplying by the reciprocal, and that's where I'm getting the 6 from. And so now the point x comma y, okay, well, and there it is. We're looking for that image point. It was going to be 2x, 2x plus 6, and then 2y plus 1. And then this one right here, there's nothing really particularly interesting happening in the image point. That's simply going to be x plus 5 and then negative 2y plus 4. What's interesting about this question is that we actually give you the answer. We give you what it becomes. So in this case, I'm not plugging 6 into x and adding 5. What I'm saying is I added 5. Oops, I don't need that. I added 5 to x and got 6, which means x should have been 1. Okay. To get that negative 1, I have negative 2y plus 4. So I'm going to bring that 4 over. It'll be negative 5. Then I'm going to divide, get 5/2. So the original y coordinate was 5/2. So this question is asking you to go backwards, and you want to be on the lookout for that. It's a very subtle little change in the problem here. Okay, the point that I'm going to give you is on the transformed function, not on the original. Okay, now we're just going to finish up with these two questions here. Determine the equation of f of x after it's gone through. Okay, here we go. So a horizontal stretch by a factor about the y-axis of 2. So that means I'm going to replace x with 1/2 x, followed by a translation of 3 to the right. Okay, and that's going to be x minus 3. So I start with y equals f of x. I remove the x and replace it with 1/2 x. Now I'm going to remove the x again, but notice in that previous step, I was multiplying x by a half. So now I'm going to replace the x with x minus 3. But in this case right here, I actually haven't done the replacement because I should be multiplying what x is now by a half, which means I have to include the 3 in it. So in order to make that work, I have to put parentheses around that x minus 3. Now I've replaced the x. And in this next question here, and yeah, I figured this was what's going on here, we're going to replace x with x minus 3, and then we're going to replace x with 1/2 x. We're going to do this in the backward order here. We're going to do the translation first. And I know we've talked about this before, but that means that the translation that I was told is actually not going to be what it looks like at the end here. So this is going to be f of x minus 3. So now what I'm going to do is I'm going to replace x with 1/2 x. Now, in this previous step, I was subtracting 3 from the x. Now I'm going to be subtracting 3 from 1/2 x. Okay. I don't need to put parentheses around that to do that substitution because it's not a multiplication. I'm not worried about distributing anything through. I'm just going to subtract 3 from that product here. But what I will do at this point now is factor that 1/2 out. And this is where things change a little bit. And we've already seen this here. That -3 is going to become a 6 because we're going to take that -3. Once again, we are dividing by 1/2, which is the same as -3 multiplied by 2/1. That's division by that fraction. And so actually what I'm looking at here when all's said and done is that actually looks like a stretch by a factor of 1/2 and a translation of 6 to the right.